Hello everyone. Today we are going to uh, analyze the frame and find the support reaction of this frame with an inclined member. And here we have a roller support at A, and then we have internal hinge at B, and then we have a rigid joint at C, and then we have a fixed end support at D. So the first thing to do is when you're trying to analyze a structure is to check the determinacy if you can use all the equilibrium equation or not to find all the unknown reactions. If equilibrium equations is sufficient, then we call those as determinate structure. And if they are not sufficient, which means that if number of unknown reactions are more than the number of equilibrium equation, then we have to classify those as uh, indeterminate, which means that we will need more additional equation to solve the unknown reaction. So in this case, A is a roller, so we know that it will have only one reaction, and D is a fixed, so it'll have three reactions: dy, dx, and a moment md. And this is internal hinge, and because it is internal hinge, moment will be equal to 0, so which means that it will have only two reaction, bx and by. And because this is an internal hinge, so we can break the structure at the internal hinge and count it this AB as one member and and BCD as one member. So what does mean? Means that this will be considered as the first member and this will be considered as the second member. Now we can use the equation to check the determinacy, which is R and 3n. And let's count how many reaction we have. We have here 1, 2, 3, 4, 5, 6. So there are 6 reaction and we have we have 2 member. So 6 is equal to 6, which means that this is statically determinate structure, which means that we can use equilibrium equations to find all the unknown support, which is your ay, dy, dx, and md. The first thing that I see with the students is they trying to use equilibrium for the whole structure. The difficulty in that is you have here three unknown reaction and you have here one unknown reaction, so that will give you um, four unknown reaction, but you can only use three equilibrium equation, so you will not be able to find all the unknown reaction. And then another thing that I see is they will use this structure to find all the unknown, but again this has 3, this has 2, so it has 5. So because it has 5 and you have only 3, so you might not be able to find all the unknown reaction. So to because in the especially in your FE exam or in your exam, timing is very uh, important. So you have to find a way that you can solve the equation in an efficient manner. So for this, you'll see that this AB has 1 and an internal hinge has 2. So we have 1 and 2, 3. So that means we can use 3 equations. So which is why in this case, we will use the beam AB to analyze the frame first. And because this load is along the gravitational direction or gravity, so we call this as a dead load um, or dead weight load, and this will be 80 kilonewton meter. And the first thing we need to know is what is the length of AB. So for this we can use Pythagoras theorem, which is square root of 4 square plus 3 square, and that will give you 5 meter. So this length is 5 meter, and we have here by and bx. So for this, we can uh, draw the, we can consider an unit load, sorry, a point load, and that point load for this UDL or uniformly distributed load as 80 into the whole length. which means that 400 kilonewton. We just convert this into a point load so that it will be convenient for us when we calculate the moment. Otherwise, if we cut a section, we should not convert into a point load if we cut any section in between A, B. So for this case, because I wanted to know what is my AY, so I will convert the UDL into a point load, and that will be 400, and this will act exactly at the center. And so for that, because we need AY, so we're going to take moment about P is equal to 0, and that will give me AY into 4, and because this is clockwise and it's negative, and then we have 400 into 2. Like I said, it will act exactly at the middle, so that means this will be from here to here is 2 meter. 2, and because this is counterclockwise, it will be positive, that will give you 0, equal to 0, because there's no more force that will apply moment at B. So this implies that AY is equal to 200 kilonewton, and because it is positive, so we say that our assumed direction is correct. If it is negative, then we have to change the direction that we assume. So once we have AY, now we can solve for the whole structure, for this whole structure, because this is known, so we have only here, now we have only 3. And because the question is find all the support reaction, so we don't need to find the internal reaction, unless we have to draw the, if we have to draw the bending moment diagram, shear force diagram, axial force diagram, then we may need to find this internal hinge. But for this case, we just need to find the support reaction, so we don't need to solve for Bx and By. Now for the whole structure, we can take summation of moment at D is equal to 0. We'll have minus AY into 8, because AY will produce a clockwise moment, so that's why minus, and we have 400 into 6, and we know that it'll be the point load for this uniformly distributed load will be 400 kilonewton, and the distance of that point to D is 6 meter. And then we have minus 80 into 3, because this point load, horizontal load, will apply a clockwise moment, and then we have counterclockwise moment, and then we have MD, which we assume as counterclockwise, and that will be equal to 0. And you'll see that MD, if you put all the value for AY we already found, which is 200 kilonewton, you'll find that your MD is equal to minus 640 kilonewton meter, or we say 640 kilonewton meter, and our direction now will be clockwise, because we have found that we assume that it is counterclockwise, but because we get negative, so that means our direction should be opposite. So that is how we find for MD, and now we use find for summation of all the force in y direction, and that will give you AY minus 80 into 5 plus dy should equal to 0, and this implies that your dy is equal to 200 kilonewton, and because it is positive, so we know that your direction, assumed direction, should stay or remain the same. And then finally we found summation of all the force in x direction, and that will give you dx, because this position, the direction of your dx is positive, and also 80 also is positive, so which means that dx must be equal to 80 kilonewton or 80 kilonewton in the opposite direction. So we found all the unknown reaction. So we find AY, We find the moment at D and vertical reaction at D and horizontal reaction at D. So that's how we solve or analyze the frame and find all the unknown reaction. If you have to draw the shear force diagram, bending moment diagram, and axial force diagram, then in that case you need to also find what is the internal reaction at hinge B. Okay, that's it. Thank you.